Hello everyone. Hello Olivier.
Good morning.
Hello Professor Stark. I'm very pleased to be with you all today. I am Valérie Ferret and I'm the Vice President of 3D Experience CDU. It's our education department in Dassault System. And we are here with you, Professor Stark. You are the head of the Industrial Information Technology Department in TU Berlin. You have been spending half of your career in the automotive sector, leading product development in global OEMs. And you have been in TU Berlin for 16 years, I believe, if I'm correct, yes?
Yes.
And you also hold various positions in a very strategic organization in Germany for science and engineering. You've just been appointed as a member of the advisory board for Industry 4.0 research. And Olivier, you are the CEO of CATIA. CATIA is our global brand and solution to model and simulate virtual twin experiences.
Yes.
And you have been in Dassault System, you don't want me to say, I believe, but for, let's say more than 2 decades. A bit more.
Correct.
And so we are here together today to discuss skills. We will be talking about first the industry transformation and obviously then the skills that are needed by the industry in order to address this transformation. So I will start with you, Olivier.
Okay.
I think you have a unique perspective as the CEO of CATIA on the transformation that are happening not just in the manufacturing sector, but in the infrastructure and city sector as well. So what are the key trends that you see in the industry right now?
Well, thanks. Let's start with that. And I think, you would agree that the trends and we are experiencing right now are somehow very different than the one we experienced a few years ago, right? It's no longer about how designing parts in 3D, how to do a little simulation aside. It's really about taking large programs, such as in automotive, aerospace, high-tech, and how to reduce the overall lead time. And at the same time, the product is becoming more and more complex. If we want CATIA to address engineers, it's not anymore about just mechanical. It's about electrical, electronics, software. So the system dimension is very important. And you mentioned sustainability. By the way, it's true for the manufacturing sector. It's true also for very large infrastructure project, construction project. And actually, this sector is learning from what did happen in manufacturing to try to do things differently, much more efficient, and putting in place key principles like circular design and so on. And also, all these projects are a global, very international, global project where engineers all over the world need to find a common language. So we hope that virtual twin could be one of these languages.
Well, we know that virtual twin is one of these languages. So indeed, a strong transformation, as you said, it's all about digital transformation, but not just for some practices, but all over the sector, all over the enterprise. It's all about sustainability as well, and it's all about collaboration under a new language, virtual twin experiences and new practices. A lot of transformation indeed, and so for you, Professor Stark, I'm sure that it triggers a lot of transformation also in the education world in order to make sure that you provide the industry with the skills that they need. So how do you see today the future of engineers? For your students, how do you prepare them to really lead those kind of transformation in the industry?
Yeah, I think you both have mentioned the challenge we have ahead, transformation. Now, scientifically, a transformation is a very clear-cut modification where you know the beginning state and the end state, but the transformation we are ahead of us in industry, it is not that precise. So what we have to do with the next generation of engineers and also with the people in industry, we have to help them to understand that we have now different tasks, which we didn't have in the past, because sustainability really requests now the full life cycle activity, not just until the job one and the entry to the market. And therefore, we have a lot of different disciplines which we have to connect to each other. And even if they use different kind of connotations and models, this is now really the way of how we want to bring in the study of engineering the people to make them aware of it, but also that they learn the practices. And therefore, system model is one aspect, but also integration of different tasks into one digital environment. That is quite important to really make an impact. And therefore, we are really looking to combine the new technologies we have on the digital side, which is part of the digital transformation, to leverage them to really make the big global transformation to a more sustainable life and to a more sustainable industry. And we have different type of formats of how we are going to use that and how we explain and educate the next generation of engineers.
So definitely industry and education partnering strongly together to make sure indeed that we address this transformation and build a more sustainable world. And it's indeed about technology, Olivier, because as you said, it's transforming the world. We said that the Katia promise is to shape the world
we live in.
And it's all about shaping a full new world. And there is a lot of new technologies, discipline that help do that. Can you tell us a little bit more about that?
Yeah, new technology, new skills. As I was starting to talk about in terms of trends, complexity of products. You know, if you take the example of car development, they talk about software-defined vehicles, which means that a lot of innovation will come from software, but you need to check the combination of software with the hardware as well. So what does it mean in terms of skills and technology? It means that more and more we need multidiscipline approach. You know, people obviously having the deep expertise on one given domain, but having the capacity to abstract at the conceptual level to define specification of the system, architecture of the system. So we need to train engineers of tomorrow to address that in the right way. We call it a cyber physical system, which means cyber from the governance standpoint, the control, so which means how to bring software and hardware to address complex problems like software-defined vehicle in the car industry. So system is really the number one. Number two trends in terms of technology and skills is we've seen a number of industry and clients, companies who really want to hire new engineers in the future that are mastering both modeling and simulation. We used to call this ModSim. So I don't know if a ModSim engineer will resonate in education, but basically it means that if you're an engineer, you want to quickly check whether your design, what is the impact on the environment, CO2 emission, water consumption, or the performance in terms of safety, and which means that you need to master modeling and simulation at the same time. And last but not least, I will talk about data. I think that with the coming trends of artificial intelligence that will bring acceleration in the way we can explore new alternative, new design, it's all about data. So engineers will have to master the way to structure the data and to put on this data information, knowledge, know-how, so that it brings value to processes, to engineering processes like in manufacturing sector, construction sector, life sciences.
Talking about data, I have seen an amazing case from one of our leading customers in the automotive industry, where indeed during the engineering and design phase, they were able to have access to data from procurement, to have access to real-time information about the price of materials such as aluminum. So it's fully changing indeed the collaboration across the company. It's not just engineering and then procurement, is having access to the data at the right time to be able to be more efficient in your engineering practices.
We need to teach engineers how to navigate into the complexity in order to take the right decision.
So you talked about system, you talked about mod sim, you talked about data. All of this is within the virtual twin experiences. Can you tell us more about what are really virtual twin experiences?
Well, if we want to demystify virtual twin, it's really about capacity to model and to simulate the virtual twin from the very early inception phase up to the certification and the operation and support. So it's both part of the loop, right? The creation loop and the operation. You need to connect it to data, getting the capacity to structure the data. We have the right platform to get this data, to have the right ontologies in order to make the virtual twin structured, and then we connect that to collaboration to make sure that then you can do configuration management, program management. So virtual twin is really modeling and simulation plus data plus collaboration.
And Olivier, what about AI? We've been hearing a lot about AI lately. How will it transform engineering practices?
You're right. Everyone wants to talk about artificial intelligence, and of course, we're investing a lot on this topic. And in terms of value that we want to bring, it's really around three axes. The first one is that we need to navigate into a complex world, right? Virtual twin is going to connect to a lot of data, which are coming from, operation, cars, airplanes. A lot of data will come, and we're going to learn from this data. As you mentioned, if we want to anticipate the evolution of price or short of supply for a given component, how engineers can navigate the complexity and use artificial intelligence to better predict the impact and how to take the right decision. That's number one. Number two is we want to talk to Katia in the natural language. I want to chat with Katia, asking questions about how do I design a new part, how can I manufacture a composite parts with Katia, how can I simulate a crash in Simulia. So talking in natural language to a 3D Experience platform, and we start to have an element of that in our platform very soon, is essential value. And the third one is we want to use artificial intelligence to explore new alternatives, right? In the same amount of time, how can we empower engineers to test much more alternatives to get quick feedback about the performance on a given component, on a given system, and really empowering engineers to design the next innovation.
Wow, that's very inspiring. Somehow, obviously, it will change profoundly the jobs of engineers, and somehow it will make also some disciplines more accessible. Talking to natural language to Katia, I dream of doing that. Professor Stark, how do you anticipate this strong transformation in your curricula and in your practices?
Well, it has a direct impact. We are also taking care of that there is an understanding of what AI, artificial intelligence, is all about and how we could leverage it for our engineering work. So maybe if we just put it into perspective, when I was a young chap, obviously there was already a hype of AI. It was around the symbolic AI with the rule-based, okay? And we have introduced many of those areas also in the industry, but it was limited to a certain extent. Now with the new compute technology, all of a sudden we have a lot of sub-symbolic AI, that means on the data itself rather than on rules. And that has now, with the large language models during the last 2 years, because of ChatGPT, has boosted the interest, not only about experts in industry, and a lot of companies are playing around with it, but also see limitations. Technology companies and vendors like Dassault Systèmes, but also the young students, because last year it happened first time. I didn't recognize immediately, but some other student told me after the lecture that somebody was asking ChatGPT to the topic I was just presenting, and he asked the question, I don't know whether you want to check me, but fortunately I could satisfy him. So therefore the interest of young people to make effective use of this is quite high. Now we have to see how do we mix artificial intelligence, in the new possibilities like machine learning, generative AI, and so on, with our engineering intelligence. And Olivier just already explained it. We want to do it, to really make things faster, that tools can be easier being used. You get assistance in your engineering work. Therefore, you have more time to look ahead for the whole life cycle, for the sustainability aspects. Then it's about decision making, a lot of data. And I still have a dream, and maybe we can do it together between TU Berlin and Dassault, that also bring AI to the managers, that they can start making design changes themselves in conference rooms rather than doing all the difficult things. So therefore, we should see it as an enabler, but we also need to be a little bit, I wouldn't say strict, but also careful that we are still on top of it. And that is now the big challenge we have in the discussion, how far we want to get with AI.
Okay, so yes, definitely a lot of transformation coming up with AI. And so indeed, what we see in the education world, we've been a partner to education for more than 40 years now. Since the very beginning of Dassault system, we were transforming the job so much in the industry that we partner with education institutions to prepare for the jobs expected by the industry. Today, we have more than 40,000 institutions that are using our solution in the world as part of their curricula, from industrial design, mechanical engineering, system engineering. As you highlighted, the industry is lacking massively system architect today. And what we see is that the institution deploy our technology at really different level. So you highlighted sustainability. It can be just a course as part of the product development course. Now it's all about making sure that it's not just design, but eco-design, and that students have access to environmental information and know how to understand environmental information to optimize their product development. We see also that we have deployment of the 3D experience platform, sometimes at school level, 6,000 students collaborating on one common platform across all disciplines. So the transformation indeed is huge. And in TU Berlin, you've been a partner of Dassault System for a long time, Professor Stark. And indeed, also from your own journey from the industry to the education, you understand very well those industry transformation. From a technology standpoint today, how do you use Dassault System solution in your engineering classes?
Yeah, I would like to give you a little bit an insight of that, because it also comes from my heart. Because when I introduced the CATIA design with template-based modeling at a car OEM, I also could see that there's much more we can do, which was already striking enough, and it gave us a lot of opportunities. But when I then moved to the position of professor, I wanted to take that base technology in my head further to the next level. So I approached Dassault more than 14 years ago on those ideas, and I had really some good reactions. And we started to that time with CATIA V6 and moved gradually into a 3D experience. Why did we do that? Because from the idea, we have an evolution of engineering. And traditionally, and unfortunately still today, we have very traditional roles in industry, like there is a designer, there's an engineer, there's an analyst. We tried more than 25 years back to already integrate those kind of different roles, but it was difficult because technology to that time was not really giving all the opportunities. But now we see a cross-engineering task unification and ModSim and LCA, even from the whole life cycle, that brings now not only in a common platform environment, but also from the way of how you can interact with the tools, with the different models. And Olivier was absolutely spot on in his observation and the outlook that the data and the model we are entertaining will get officially more values, because that's at the end the enabler, but also the insurance that we know of how the future technical system, but also the engagement with society on the consumer side and so on, is going to work. Therefore, we now have, first of all, to transform the different roles within engineering to really use the new tool sets and the technologies, as I explained before, maybe also to get via networks and CATIA mechanisms, things into your design process. But on the other hand, we need to attract those people and need to reach out already in our classes to those individuals who are not so intimately close to engineering, but have to interact with it. And that is now the chance to bring a whole new generation of open-minded and technically skilled people into the next waves of industry hirings. And that is what our industry needs, not only in Europe, but worldwide. That's my strong belief, and I'm truly happy about the partnership with Dassault Systèmes here.
Well, thank you so much. It's a great testimony indeed, because what you are saying is that the 3D experience platform and virtual twin experiences allow not just the engineering to innovate, but across discipline or across the company. And it's all about making sure indeed that this innovation is as fluid as possible between all the departments and all the disciplines. This is really indeed how we will be able to really have disruptive innovation to really shape a full new world. Now there is a topic I think that is a challenge for all of us, either in the industry or in the education, is indeed we will need a lot of engineers over the next decades in order to make sure that we are leading the transformation that the world is needed. And what we foresee in Europe, but also in the US, is that today indeed we have a lack of engineers, we have a lack of people joining STEM careers. In that regard, what is your perspective on that? And I would add specifically a topic dear to my heart, which is specifically regarding women and regarding girls in STEM. How do you address this topic of attractivity of engineering and STEM careers for everyone, and especially girls? I would like to hear from you about that, Professor Stark.
Yeah, I think you really explain the motivation and the challenge here, which is absolutely true. And my answer to that one is we try 2 or 3 things to really attract and to explain the opportunities of digital technology to the young generation who are still at school before they decide what they might want to do in the future. So I think we have the opportunity that we explain and motivate to the same time. So it's a little bit like we need to bring back, let's say, the inherent motivation to say, I am a créateur de monde technique and durable. That means I really want to be part of actively contributing to a sustainable future. And the digital technologies, the tool sets we can bring to them, where they can play with it, see the influence of what you can influence at all. And digitalization and the tool sets are a strong enabler to do that. But we need to really go and reach out to those who don't have all the knowledge, and need to do it in a way that they really can follow, understand, and can step by step get their own idea about it, that they want to contribute and want to be part of the team for the future. I think that is a very strong motivation also for myself and my team here in Berlin, that we reach out now to those kind of schools where they're 2 or 3 years before their final diploma already gets an idea of what they want to do in the future, because we truly need them. And absolutely critical is that we need, at least in Europe, also in Germany, to attract more girls and women, because if we leave them out, we are missing important knowledge and intelligence. But also we need, as you just said before, we need more qualified people, and there will be a lot of very responsible jobs where I think we also need to be more attractive on that side.
Thank you. Indeed, we see that who we call the Zoomers now, I think, the Gen Z, we know that they are very active, they want to contribute, they are proactive. So let's have them here, indeed, that science, industry, engineering is a unique way to contribute and to build a new world, a new and more sustainable world. And for you, Olivier, I know that you go to classes, to university quite often. You sent me some pictures of you teaching in engineering classes. How do you inspire the young generation for engineering and science?
I think that I just would like to echo what you said, Professor Stark. By the way, congratulations for the initiative you have getting more women in engineering. And I think for me, important thing is communicating clearly about the purpose we have. I mean, trying to insist about the societal value that we bring with our solution. Yeah. Because up to now, it has been maybe a world between engineers who are, and it's not well known about what is the final value for the end consumer in terms of sustainability, circular design, in terms of creating fantastic innovation in new cars and airplanes. So the more we explain the purpose, and the more we are going to attract new type of engineers, including female, because at the end we can make engineering cool.
And
you know, we want to shape
cool.
the world.
Yes.
So isn't it a very nice purpose to achieve for a career?
Definitely.
So we need to pitch that.
Yes. Okay. So let's take that all together to make sure that together we will partner even more to make sure that engineering is more known, that STEM careers are more known in the way of the societal impact that they have. We can do more, I think, all together for that. And with that, I think it's been quite highlighted how much education and industry are partnering together very strongly to lead the future transformation, need the right talents. So I want to thank you very much for being with us today, Professor Stark. It's enlightening, and what you are doing with your students in Germany, in Europe, to transform engineering, I think is really leading the way and showing the example for others to join in. So thank you so much for the great partnership we have together. Thank you, Olivier. And next time you go to TU Berlin, you go to teach a class to some engineering students.
Let's see, let's discuss with you, Professor Stark.
Absolutely.
Okay, thank you very much.
Bye-bye.